Hi there, welcome to another video. This time we are covering section 9.2, and this is merely a continuation of section 9.1, which talked about graphing. We're just expanding on graphing here by using intercepts, more specifically the y-intercepts and the x-intercepts to graph the equation, okay? And I will explain what that means. Let's see. The important information to remember here is the word intercepts. Hold on. Let me post this. There. The word intercept, that's a word you need to memorize. That means this intercepts here and this intercept here. Where you graph crosses the y-axis. Let me expand this window here. There. Where you graph crosses the y-axis, that's one intercept. That's a point, and that's an order pair. In this case, it is the order pair 0, 4 or 0.04. Your x value of 0 and your y value of 4. Okay, that's the y-intercepts. So you need to memorize these two y-intercepts and your x-intercepts. Your x-intercepts, of course, is where you graph crosses the x-axis. Okay. Now, since we are only going to work with linear equations, in other words, lines, straight lines, notice that we're going to have the graph is going to cross the y-axis and the x-axis somewhere. Okay. Even if you have a line like this or like this, so you're still gonna, the graph is still gonna cross the y and the x-axis somewhere. So it's gonna be touching 2 points. Okay. Okay. Even here at the negatives, it's still gonna cross the x and y axis. Okay, x and y axis. Okay. Therefore, if we can find those two intercepts, we will be able to plot any linear equation, okay, any linear graph. So that's what that means, and that's what we need to know about y-intercepts, about intercepts in general. How do you well, let me take this graph here as an example. How do you, well, what's the best way to know your x and y intercepts? Well, let's say I have this graph here, this graph here, this one here, and I'm just doing this at random. Okay, so right about there. Okay, and some other one here at the bottom somewhere, right about there, let's say there, and graph it. Okay, let's look at this graph here first. Notice that we have let me get even closer to it. Yeah, that's better. All right, so notice that this graph, this one, crosses the y-axis at this point, and at this, and the y and the x-axis at this point, Well, what is the order pair for this point? That's your y-axis. The order pair is 0 for x and 2 for y. So 0, 0, 2, 0, 2. All right. And notice that here for your x-axis, for your x-intercept, the order pair is 3. So because you move 3 on the x-axis first, and you do not move up or down, so that's 0 for y. 0 for y. So you have your x-intercept equals 3, 0, 3, 0. Okay, so let's look at this graph here now. Okay, the intercept, well, the x-intercept is here and the y-intercept is here. So what are the order pairs? Well, the x value comes first, so 1, 2, 3, 4, 5, negative 5, and 0 for your x-intercept. Okay, and then this order pair for this intercept, for the y-intercept, is, well, we don't move to the right or to the left, so that's 0 for x, and negative 4 for your y. Okay, so the y-intercept is at 0, negative 4. Okay, so now let's look at this graph here. Where does it cross both axes? At this point and at this point here. Okay, so what are the order pairs? The order pairs are 1, 2, 3, 4, 5 for x and 0 for y. The order pair for this x-intercept, for the y-intercept, see, that's the y-axis, that's the y-intercept, that's 0 for x and 1, 2, 3, 4, 5, negative 5 for y. Okay, so now I want you to notice the pattern here. We got a bunch of zeros here. We always got a 0 there. See, for all these intercepts we got 0 somewhere. Then the question is, where do you get zeros for your y-intercepts? Well, let's look at the y-intercepts. The y-intercepts for these graphs are here, 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 and here. Of course, where the y-axis is, right? So this 1, 2, 3, these 4 points are your y-intercepts. Okay, and the values for those are 0, 4, 0, 2, 0, negative 4, and 0, negative 5. So notice that all these zeros are the x values. Okay, this is an x value, this is an x value, this is an x value, and this is another x value. So your x values are 0. So that happens every time you have an y-intercept. Your x value will always be 0. Okay, so for so that's what this box right down here is telling us. For your y-intercept, your x will always be 0. Okay, x is always 0. Alright, so let's look at the y-intercepts. The y-intercepts, the x-intercepts. The x-intercepts are here, 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 and here. Okay, that's 4 points or 4 order pairs. So the order pairs are -5, 0, -2, 0, 3, 0, 5, 0. Okay, so notice that the zeros are all the y values. Okay, y values. So for all your x-intercepts, your y values will always be 0. Okay, so that's what this is saying down here in the box. For your x-intercepts, all your y values will be equals 0. And that's all the time, that's every single time. Okay, so you need to memorize this. For all your x-intercepts, for all your y-intercepts, x is 0. For all your x-intercepts, your y's will always be 0. Always. And if you can remember that, you should be able to work examples like this. I mean, problems like this. Well, problems like this example here. So it's asking us to consider this equation, and it's asking us to find the x-intercepts. Then we need to graph the equation using the intercepts. See, that's why it's important to know how to find intercepts, so you can graph equations using intercepts. All right, in this case, it doesn't make a difference where we start. If we wanna find the x-intercept or the y-intercept, because we know that if we set the other variable equals 0 and solve for that variable, then we're gonna get an order pair. So watch. So let's say I wanna know my x-intercept, and I know that for all my all my x-intercepts have a y value of 0. Okay, x-intercepts have a y value of 0. So now I need to look for my x value. How do I do that? I use the equation they give me. I'm just gonna write it here. Write it down here on my paper. 4x plus 3y equals 12. And then from here, since I already know the value for y, I would substitute this y for 0. So I'm just gonna rewrite this part here and this too, and then just substitute 0 for y, and this multiplication, 0 times 3 is 0. 4x plus 0 is just 0. I mean, yeah, well, this is 0. So rewrite the x, 4x I mean, equals 12. So now you're here. Use the multiplication principle. In other words, I'm multiplying here, therefore I divide by the number I'm trying to move, and I do it to both sides to keep the equation balanced. 4 divided by 4 is 1. 1 times x, just x, equals 12 divided by 4 is 3. So x equals 3. Okay, so this x equals 3. So now I found my x-intercepts. Okay, alright, so what if I want to find my y-intercepts? Oops, there, y-intercept. Well, I know that for my y-intercepts all my x values are 0. All I have to do now is find the y. y value by using the equation they give me. And I'm gonna go ahead and write the equation down here. 4 plus 3y equals 12. And then just substitute the x value for my x here, and rewrite everything else, and solve for y. Okay. Notice that I'm plugging in the x value and solving for y. So those are two different things. For them 0 is 0 plus 3y equals 12. This goes away. Rewrite that 3y over here equals 12, and then use the multiplication principle. Since I'm multiplying here, I need to divide by 3. I need to do that to both sides to keep the equation balanced and to keep it mathematically correct. 3 divided by 3 is 1. 1 times y, it's just y. 12 divided by 3 is 4, and my y value is 4. Right over here, that's my y-intercept, and that's it. That's all you have to do, because now you have 2 points, 2 order pairs, and these are gonna be the x and y intercepts. Okay, so now I'm ready to graph. So let me turn the page here, because they have the graph on the other side. They have it right here. Hold on. There. That's the graph. Okay. All right. So if I'm looking at my work, my x-intercept is 3, 0. So I know that my x-intercept is gonna be a point on the x-axis somewhere. If it isn't, then you did something wrong. So my x value is 1, 2, 3, positive 3. So I move to the right, and my y value is 0, so I don't move at all, and plot my point there. Plot there. So that's my x-intercept. And then for my y-intercept, my x value is 0, so I don't move to the right or to the left at all. My y value is positive 4, so I move up 1, 2, 3, 4 units and plot my point there, and that's my y-intercept. If your y-intercept doesn't fall on the y-axis, you did something wrong. Okay, plot it there, and then just use your ruler and trace it. This is how you would do it, and then you have a straight line running through there. And this is why you need to get graphing paper if you can afford it. If not, just go ahead and use the ruler, like the numbers in the ruler, separate the units equally, and you should be able to do a good job, an okay job, you know. And you need to get it as accurate as possible, because it's gonna ask us to draw another point somewhere on the line and see if that's correct, because here at this table here I do have my two intercepts, but then they added another point, and they went like, what if I choose x at random, -2, what would my y value be? Okay, I rewrite my equation, which was 4. Oops, I'm just rewriting my equation here. Okay, 4 x plus 3y equals 12. All right, That was my equation, and I chose -2 for x at random. Plug into the equation, 2 plus 3y, rewrite everything else, and go ahead and solve for y. Okay, 4 times -2 is -8. Rewrite everything else. Okay, in this case, I'm gonna need to move the constant first over to the other side, because it's easier this way instead of moving the 3. Okay, multiplication division you do last. Okay, so the addition principle tells me to add the number I'm trying to move on both sides. This cancels, basically cancels out. Rewrite 3y equals 12 plus 8, that's 20. Use the multiplication principle now. It tells me to divide. Since I'm multiplying, I divide the number I'm trying to move by the number I'm trying to move. That's 3. Do it to both sides to keep the equation balanced. That's y. 3 divided by 3 is 1. 1 times y is just y, equals 20 divided by 3. Well, that's not going to divide evenly, so all you can do is simplify it if you can, but you can't. Well, in this case they simplified it out to a mixed number by doing this. 3 goes into 20 6 times. 6 times 3 is 18. 20 minus 18 is 2, and I stop there because then I'm gonna get a decimal. I don't want that. I want a fraction. So I use these 3 values to get my mixed number. Since I got, well, let me see, let me rewrite this mixed number as this. I know I need whole units here. Since I got 6 whole units out of there, that goes here. I'm done with that. I always keep my denominator. The denominator was 3, so I write it here as the denominator also. Get rid of that. The only number left is 2. That goes up here. That's it. 6 2/3. So that's what they had here. So now I can see that my y value is 6 2/3. So let's see if I plot that. Where would that land? Well, my x value is -2. 1, 2. My y value is 6 2/3. 1, 2, 3, 4, 5, 6, and about 2/3. That lands me right there, right on the graph. So let's go back to the question. What were they asking? They were asking find the intercepts, to find the intercept and graph the equation using the intercepts, and we did all that, except for we found the extra points that told us that the work was correct. Okay, this extra point was a check. It was a check, and it told us that this graph was correct. Okay, so you do a third point, like I told you before, as a check. Okay, if your check doesn't fall on the graph, if it falls on either side of the graph, then you did something wrong. You gotta go redo your work, or find out where you made your mistake. Okay, so let's move on to the next example. And in this example, they are asking us, what are they asking us? Graph y equals 3x. We know that 0, 0 is both the x-intercept and the y-intercept. We calculate values at two other points and complete the graph, knowing that it passes through the origin 0, 0. Okay, so what are they saying here? Well, let me show you. Because let's say you didn't know what they meant and you have to find out. Well, if they were asking you to graph this equation, what you would do is find the x and y intercepts, right? So the x-intercept is, well, I know it has a value of 0 for your y. The y-intercept has an x value of 0. Okay, so to find my x-intercept, my x value, I need to plug in 0 into the equation and solve for x. So that's 0 equals 3x. If I plug in this 0 into the equation, it's gonna give me this. I need to solve for x. Use the multiplication principle. Divide. 3 divided by 3 is 1 times x. It's just x. Do it to both sides. 0 divided by 3, that's 0. X equals 0. So your x value is 0 for your x-intercept. For your y-intercept, just substitute the value of 0 for the value of x. For the variable x, yes. Y, that's gonna give me y equals 3 times 0. Okay, if I substitute x, 0 for x here, it's gonna give me this. Now I'm here, solve for y. 3 times 0 is 0. My y value here is 0. So notice that we have 0, 0 for the x-intercept and 0, 0 for the y-intercept. Both of them are the same. What is that saying? That's saying that your graph crosses at the origin. That's what that's saying. Okay, I don't know if you can see it, but it is true, because notice that the y-axis is crossed at 0, 0. The x-axis is crossed at 0, 0 also. And so this is correct. This is not a mistake. This is correct because the graph does cross both the y-axis and the x-axis at 0, 0 at the origin. Okay, so that's what this means. And see, the thing is that we wouldn't be able to graph, we wouldn't be able to know the slope of this graph. So I could have something like this, see, a graph like that, and still be correct with my numbers. See, because this graph, the one I just drew, it still crosses the x and y values at 0, 0. So, and I could have done this for a lot of different graphs, and the information still will be correct. So that's a problem. That's a problem because we won't be able to graph this equation with just this information here. So for that, we're gonna need some extra points. Yeah, we need to find out some extra points, but you already know how to do that. Okay, make sure you choose values for x at random. Values for x at random. Solve for y, and I'm just gonna rewrite my equation from the top. Okay, so that's my equation. They chose -1 for x at random. Let's do that one first. Let's substitute -1 for x. So your y value is -3, because you multiply positive and negative, it's gonna give you a negative. 3 times 1 is 3. So that's your y value there, -3. That's where they got it from. For your x value, well, just substitute that into the equation. For the x value of 1, y equals 3 times 1. Now that's a positive, so y equals 3, positive 3. So that 3 is this 3 right here. Okay, and now we have 2 extra points. We can plot those, and it's gonna be okay to use these two values, these two order pairs, because the values are integers. Okay, they are not fractions. Okay, if you get fractions here, remember to use a different value for x, like -2 maybe, or +1. I mean +2, until you get an integer. Okay, or else you won't be able to plot them correctly. Okay, so we said that the points, the two new points were -1, -3, -1, 1, 2, 3, -3 for the first point. Plot it right there, and then for the other one, move 1 to the right because it's positive, and then 3 up, 1, 2, 3 because it's positive on the y. Okay, plot it, and now you're able to graph that equation. See, because now you have 2 points, and you know the slope. You know the slope of that graph exactly, because these 2 points told you that. And let's see what else. And you're done. You're done because that's all they wanted. They just wanted you to graph it. You could have used this information. More than likely, you were gonna look for the x and y intercepts, but then you would have seen that both of them were the same, and you can't graph an equation like that because you wouldn't know what the slope was just by that information. So because all these graphs here, all of this have the same information, they cross at 0, 0, 0, 0. Therefore, you need 2 other points, or at least 1 more point to graph the exact slope of that graph, of that equation. Okay, and then just add another point for check. Okay, because remember, you need 3 points, at least 2 points to graph it, and then a third one to check it. Okay, all right, so let's well, in this case we need to practice section A, because that's the end of section A. So we need to practice now. Let's see if I can find some examples to practice from. Okay, so you're gonna have questions like this. For each exercise 1 through 4, find the coordinates of the y-intercepts, and B, the coordinates of the x-intercepts. Again, I think it's simple because for your y-intercept, that's where your graph crosses the y, so it's right here. So the value for x is 0, the value for y is 5, positive 5, so 0, 5. For your x-intercepts, well, it's gonna be this point right here. The value for x is 1, 2, and the value for y is 0 because you do not move up or down. It's right there. On this one, the y the y-intercept is right there at 0.03. So 0 for x, 3 for y. 0, 3. The x for the x-intercept, that's gonna be order pair 4, 1, 2, 3, 4, 0. 1, 2, 3, 4, 0. This one for the x-intercept, the x-intercept is gonna be at 3, 0. Okay. 3, 0. For the y-intercept, that's gonna be at 0, negative 4. 0, negative 4. Remember that the x always comes first, so don't mix them up. Don't write negative 4, 0. No, because 0 is your x and negative 4 is your y. So the order pair is 0, negative 4. Alright, for this one, the y-intercept is 0, positive 5. And for the x-intercept is negative 3 on your x, 0 for y. Alright, let's move on. The coordinates, for each of this, find the coordinates of the y-intercepts and the coordinates of the x-intercepts. Do not graph. Okay, so here we're not graphing. Let me just work one of them out. Or maybe even two, because, and I don't see any big variations here. So, well, probably the only different problem would be these two. So let me work this one out. Number 11. Oh, number 11. Yeah. And it's asking us for the y and the x-intercepts. Okay. So for the y-intercept, I know that my x values are zeros. Okay. So you substitute your x value to the equation. That's 6 times 0 minus 3 equals 9y, and then solve for your y. Okay. So 6 times 0 is 0. 0 minus 3 equals 9y. Rewrite this as negative 3 equals 9y. Now I need to move the 9 from, to leave the y by itself. So I use the multiplication principle. The multiplication principle tells me to divide, since I'm multiplying here, divide by the number I'm trying to move, do it to both sides to keep it balanced. 9 divided by 9 is just 1. 1 times y is y. And here, just simplify, make sure you simplify. That's negative 1 over 3. Okay, so your y is negative 1 over 3. Here we got a fraction. That's okay, because we don't have to graph it. Okay, so that's your y int. What about your x int? Your x-intercept. Well, for your x-intercept, what are your zeros? Is it the x or the y value? Well, the opposite. If you haven't noticed that already, so here the y, for the y-intercept, the opposite was the 0. For your x-intercept, the opposite variable is gonna be the 0. Okay, substitute that value into the equation. So substitute y into here, and you're gonna end up with, let me just draw a line here, and you're gonna end up with 6x minus 3 equals 9 times 0. Alright, then you solve for x. 6x minus 3 equals 9 times 0 is 0. Okay, here remember to move the constants first, any addition or subtraction, and worry about your variables at the end. So in this case I'm using the addition principle. Since I'm subtracting here, I need to add 3 on both sides. Negative 3 plus 3, that cancels out. So rewrite your 6x, not just your 6, but your 6x. That's equal 3 plus 0, it's just 3. Okay, this is not 0 divided by 3, no, you're adding here, okay? So be careful with that. And you're adding 0 plus 3, so that should be 3 here. Since I'm multiplying here, I need to use the multiplication principle, which tells me to divide by the number I'm trying to move. Do it to both sides. 6 divided by 6 is 1. 1 times x is x. Here, all you can do is simplify. 3 divided by 3 is 1. 6 divided by the same number, 3, is 3. I mean 2. So 1/2. So your x int is 1/2. Okay, and that's how you would work this out. Okay. All right. Let me just work one more, because this section is gonna be short, I think. So we have a bit more time to work on this example. So let me just fold the paper here. And oh, and by the way, I can't cut the video because I need to get it all in one take. Okay, so yeah, in case you were wondering why I don't cut the videos, because it's easier that way easier. I gotta get it all in one sitting. Okay, so what are we doing? We're trying to find the y-intercepts, and that's 0 should be the opposite of y, which is x, and substitute that x into the equation. We're working on number 12 here, so just rewrite everything else. X minus 2 equals 6, and then substitute your x for your 0 for your x here. Okay, so that's go ahead and work it out. Solve for y. So rewrite this side here equals 0. 6 times 0 is 0. And then use the addition principle. Remember to auto subtract first before you work on your variables. Plus 2. Do it to both sides. This adds up to 0. In other words, it cancels. So just rewrite 4y equals 2, because you're adding 2 to 0. Okay. In this case, we need to use the multiplication principle. Because we were multiplying here, we need to divide by the number we're trying to move. Do it to both sides, and you're good. Mathematically correct. 4 divided by 4 is 1 times y is y equals, here all you can do is simplify. 2 divided by 2 is 1. 4 divided by the same number is 2. Okay, so your y value is 1/2. Okay, what about the x-intercepts? Well, the zeros for this should be the opposite. In other words, the y should be the 0. And substitute into the equation for your y. Okay, so that's 4. Substitute is 0 for your y, and rewrite everything else. Now solve for x. 4 times 0 is 0 minus 2 equals 6x. And then this is -2, essentially -2 equals 6x. Okay, and here we need to have x by itself, and it needs to be positive too, so just divide by 6. So that's the multiplication principle. 6 divided by 6, 1 times x is x. Here all you can do is simplify. Don't forget your signs. Don't forget your sign that's negative, because all we're doing is simplifying. That's all. 2 divided by 2 is 1. 6 divided by 2 is 3. Okay. So your x value for this x-intercept is -1 over 3. Don't forget your signs. Alright. And that's that for that kind of example. So let's move on to this kind of problems. And the question, let me see, there. Question is, for each equation find the intercepts, then use the intercepts to graph the equations. But that's what we've been doing. You know, we've been trying to find the intercepts, and they already gave us the box here, because we know that for the y-intercept, the x values are going to be 0. For the x-intercepts, the y values are going to be 0. Okay, so they already gave us the table to work with, and then they added another extra point just for check. Okay, so I'm gonna go ahead and find the x-intercepts first. Okay, so I'm gonna zoom in to this part here, since we already know what the question was asking. Alright, right there, that's good. And my x is 0, so substitute that into the equation. That's plus 3y equals 6, and it's over y. So here all I have is 3y equals 6, and use the multiplication principle. Since we're multiplying here, divide by 3 the number you're going to move. Do it to both sides to keep it balanced, to keep the equation balanced, and to keep it mathematically correct. 3 divided by 3 is 1. 1 times y is y. Y equals 6 divided by 3, that's 2. This would not be the answer. Okay, you need to simplify that. And no, 2 over 1 is not the answer either. Okay, because this can be simplified even further. Okay, students make this kind of mistake. They leave this equation as 2 over 1, but that's not true, because you can still simplify this as 2 divided by 1, 2. Okay, so your y value is 2. So that's a 2 right there. So your order pair would be 0, 2, and that's your y-intercept. Okay, so let's see, for your x-intercept, substitute y value, 0 for the y value, into the equation. So I'm gonna go ahead and write everything else plus 3, and substitute 0 for y equals 6. 3 times 0 is 0. Times 0 is 0. And rewrite everything else. X plus 0 is just x equals 6. So the x value here is 6. Okay. Now notice that they got another point there for us check. Well, let's say I choose x at random, and and let's give it a 1, positive 1 value. Okay, positive 1. Okay, substitute that into the equation. For x, we said it was 1. Let me just write it down here, and I'm just using the equation there. I'm substituting 1 for x and rewriting everything else. I'm here. Okay, let me draw a line there. So I'm right here. This is x plus 3, 1 equals 6. Since I'm adding here plus 1, I need to subtract. Oops, I need to subtract 1 from both sides. Positive 1 minus 1, 0. Rewrite everything else. Well, in this case, I have a subtraction here. 6 minus 1 is 5. And then y. 3. Well, I'm just rewriting this as 3. Y equals 5. From here, use the multiplication principle. Divide by 3, the numerator trying to move. This turns out to be y equals 5 over 3. Okay, so we didn't get an integer, we got a fraction, 5 over 3. And that's basically the same thing if you turn it into mixed number by dividing. So you divide by 3. 3 goes into 5 one time. 1 times 3 is 3. 5 minus 3 is 2. You stop there because you don't want a decimal. You want a fraction. You want a mixed number. Mixed number that looks like this, right? For this place here, you need the whole units. So since we got one whole unit out of that, that goes here. And that takes care of that. Keep the denominator, same denominator always. So rewrite your denominator, that's this number here. So the only number you have left is 2. That goes up here. Okay, so 1 2/3 is the same thing as 5/3. Okay, so let me write 1 and 2/3 in here. 1 and 2/3. Okay, so roughly, I know that that's roughly where the graph should should be. Yeah. If I plot these two, the x and y intercepts, then it should go over this point too. Okay. So let me first graph these two points. Let me plot the points first, and then I graph. So the first point is 0, 2. 0. So don't move to the right or to the left. Stay there. Move 2 up. That's your y. That's your plot your point there. That's your y intercept. The other one is 6 for x, 0 for y. It's positive 6 for x. 1 2 3 4 5 6 way up here, and 0 for y. So plot it right there. Those are your 2 points. Use your ruler, and it's not going to be very accurate, but make it as accurate as possible. Okay, because this has to go over the other point, the extra point, you know, the checkpoint that you worked on a while ago, which is 1 for x, or 1 for x, and then 1 and 2/3 for y. 1 and 2/3 for y. Yeah, it's right somewhere over there, somewhere in here, and plot it, and that's a good check. So we know that this graph is okay because all 3 points are on the graph. Okay, and that's why you need to use checkpoint. Yeah. All right, and that's how you do it. Okay, that's how you do the kind of problems. So let's move on to do they have anything different? No, the only difference on these problems here, The instructions are still the same. However, make sure you use your own box. Instead of using theirs, you're gonna have to use your own box. But you already know how to do that, okay? If you don't remember, all you have to do is throw your x and y values there. Use at least 3 points. I will use 0, positive 1, negative 1. If this gives you fractions, like for example a half, use negative 2 instead. If this still gives you a fraction, use negative 3. And until you get an integer here, okay? Alright, and that's how you work out those problems. So let's move on to section B, because this section has two objectives, objective A and objective B. So here we are talking about equations whose graphs are horizontal lines or vertical lines. Well, it is very easy to spot these kinds of graphs. However, they are not as easy to graph, I don't think. Well, if you use the tables like this, then yeah, it is easy to graph, because all you do is just graph, find the order pairs and graph them and plot them and then graph it. So for example here, when the equation is y equals 3, then notice that you don't have an x in there anymore. So where did the x go? Well, don't worry about the x, because the x is gone, and y, this graph is this equation is telling you that all the values for y will be 3 throughout the board, okay? In other words, all these y values are always going to be 3, always, 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 okay? And then you need to solve for your x. Well, in this case you cannot use the y, the equation to solve for x, okay? However, you know that you're going to have an infinite amount of x values for your x, because if you look at the plane, and if you're talking about y equals points with y values of 3, so that'll be that one there. See, values of 3, y values of 3. The only points that have y values of 3 are that one, this one, this one, this one, this one. So y value 3, 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 and everything in between. Everything in between, everything in between. Therefore, that's gonna give us a whole line, a solid line, okay? That's gonna give us a solid line. And notice that this line crosses the y-axis, but it does not cross the x-axis, okay? So that's what this is telling you, that you're gonna have an infinite number of x values. So like 0, 1, 2, 3, 4, 5, negative 2, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6 for your x values, an infinite number of x values to the right or to the left, but only one value for y, which is 3. See, for all these points you have a different x value. However, you only have one value for y. which is 3 for all of these points. If you don't believe me, just go ahead and get the ordered pairs of them, and you should be able to confirm that. For example, this one is 1, 3, and for this point here, the ordered pair will be 1, 2, 3, 4, 5, 6, 1, 2, 3, so 6, 3. See, the y value is still the same. Y value is still the same. It will always be the same for that line there, because that's what this called for. That's what this equation called for. Y equals 3. Your y values are always 3, and you get a parallel line to the x-axis, basically, because this line will never cross the x-axis, never. Okay, so remember that. But so what happens if your equation looks like this? X equals -4. Well, something similar happens, where all your x values are -4, all of them. That's what this is telling you. That y went away, and your x values are always going to be -4. They are always going to be -4. Therefore, your y values is going to be infinite. Yeah, the y values are going to be infinite. You can choose any y value you want, except for your x value has to be -4. What is that telling us? Well, if all my x values are -4, 1, 2, 3, -4, so -4 here, and for this point, the x value is going to be -4. For this point, it's -4. For this one too. For this one. For this one. And for this one. And everything in between. And you can see how that is looking like a graph. And in fact, it is a graph. It's just a vertical line parallel to the y-axis. It's never going to touch the y-axis, never, because it's parallel to it. Because your x values are always going to be -4. Okay, that's what makes this vertical line, and it's going to be parallel to the y-axis, so it never crosses the y-axis, never does. And that's when you have an equation that looks like x equals -4. Okay, and that's about it. Even if you didn't know that this equation looks like a vertical line, and that this equation looks like a horizontal line, go ahead and plot the values, put values like in a box, because you know that this is telling you that all these y values, all your y values are going to be 3, and since you don't have an x value, you assume that that covers all your x values, so like from 0 to positive infinity and from 0 to negative infinity. Okay, or you could just choose 1, 0 and positive 1 and -1, because that's going to cover all at the x values. And then just plot them, start plotting them, and you're going to start seeing the pattern there, and you're going to get a straight line. Okay, so make sure you get familiar with that kind of graphs, what this is telling you, because that's going to come up in the exam and the test, and on your assignments, of course. Okay, so what have we learned? That equations that look like this with just one variable are going to be parallel lines to either the y or the x-axis. For your x equals some number, the line is going to be vertical. For your y equals some number, your graph is going to be horizontal, parallel to the x-axis. Here, for your x equals to any number, your graph is going to be vertical, parallel to the y-axis. Okay, so sort of the opposites. Okay, that's what we learned. And then we also learned to solve for y and plot two different numbers, two different values, find two different order pairs. If the graph crosses at 0, 0, because then the y-intercept is going to be the same as the x-intercepts. See, the x-intercept is 0, 0 and the y-intercept is 0, 0. So that's, you won't be able to plot the graph with only this information. So you need to find at least one more or two other points. Do two more because you want the other one for check. Yeah, for a check. So you check yourself doing that. However, if your graph crosses at any other point other than the origin, then you only need to find the other intercept. Okay, find the other intercepts, and you should be able to graph that equation. Yeah, plot another point just for check. That would be nice. All right. Yeah, this is telling you the same thing, except for you have to solve for your variables. Here, find your intercepts, and an extra point, just for check. Okay, and that's the end of that section. Except for, let's go ahead and work out at least one of these. Okay, so again, if you see an equation that looks like this, that's missing a variable, all the values for the variable they give you are always going to be the same. Okay, choose any values for y, because y is going to cover all real numbers. Okay, so I would choose 0 and 1. Well, in this case, let me choose y. 5 is fine, since it's going to be inside this plane here, so that's not a problem. Choosing 0 and +5 and -5. So now I have three order pairs. I have -2, 5. So -1, 2. Move up 5, +5, 1, 2, 3, 4, 5. Plot it. Plot my point there. I'm done with that one. Use this one. Plot it. -2, 0. -1, 2. 0. Plot it right there. You don't move up or down because that's 0 for your y. -2, 1, 2. -5. -1, 2, 3, 4, 5 for your y. Plot it, and now you're able to graph it. So go ahead and graph it, and that's your graph. It's a vertical line, in case you didn't know that. Okay, in case you can remember that this that whenever you have an x equals some value, your graph is going to be vertical. Okay, parallel to the y axis. Okay, if you have an equation that looks like this, y equals a number, well, what did we say? The graph is going to be parallel to, we said it was going to be parallel to the opposite axis. So in other words, to the x-axis. So to this axis, it's going to be parallel to this axis. So I already know, if I can remember, that my graph is going to look something like that. Okay, where exactly is it going to be? Well, the y is going to tell you the value it's going to tell you exactly where at y equals 2. So 1, 2 here. So the since I already know that it's going to be horizontal line parallel to the x-axis, and my y equals 2, my y is going to be my I should have used the ruler, guys. But anyway, you get the idea. But if you don't know that, whenever you have an equation that looks like this, and the graph is going to be parallel to the other variable, to the y-axis, to the x-axis, then just go ahead and choose points here and plot your points, and you're gonna see that it's right away if it is a horizontal line or a vertical line. Okay. And let me see what else, and we can check that this is right, because I know that for every y-intercept, what's gonna be my x value. For every y-intercept, my x value is always gonna be 0. Okay, so my x value is always gonna be 0. Okay, and if I write 0 here for my x, then my order pair is 0, 2. If I plot it, that's 0, 1, 2. My x-intercept, my y-intercept is going to be right there. So yeah, that checks. So that checks. That could be another check. All right, and that's it for that lesson. Let me see if you have anything else here. Write an equation for the graph shown. No, you don't have to do that. You don't have to do that. Let's see what else. No, well, you're gonna have fractions. Just make sure you use the rules of fractions, okay? And I don't think I'm gonna give you a problem with fractions, okay? So you're good there, okay? So anyway, that's the end of this section, and I will see you on the next one, okay?